Hello, this is Mr. Miller and welcome to video 1M. This video is about rotational symmetry. It's kind of a cool video because we have a lot of neat figures to look at and it's also quick, so let's get going. We want to identify if the figures have rotational symmetry or not, and if so, what's the angle of rotation? Well, a figure has rotational symmetry if you can rotate it and it perfectly overlaps itself. It's as if after rotating it, you can't even tell the difference. Like this star shape here, if we rotated it so that that tip rotated to here, we couldn't tell the difference. It would look exactly the same. So this has rotational symmetry, and we want to know what this angle is here. Okay, well, this is a helpful diagram to figure it out. What I did is I drew the center and I drew a line to the tip of each part of the star. So there were 5 altogether. Now remember that all the way around the point, if we turned it this way, all the way around would be 360 degrees. Okay, but we want to know what each of these smaller angles are. And there are 5 of them. And they're all equal. So to figure out what each of these smaller angles are, we do 360 divided by 5, which ends up being 72 degrees. That's how much each of these angles are. So there are 1, 2, 3, 4, 5 angles. 360 divided by 5 means that each one of them is 72. So we know the answer to the question over here. If we rotate it 72 degrees, it'll perfectly overlap itself. Okay, let's take a look at this one. Whoever Melissa P is, she has an awesome looking flower here. So the same thing. I want to know how much I have to rotate this by for it to overlap itself. Okay, so if we start here, we got to rotate through this angle to there. Rotating about the center of the flower there. Okay, so same trick. I started at the center and I drew a line to the tips of the flower there. It turns out that this time there are 6 angles. So we got 1, this one right here, 2, 3, 4, 5, 6. So remember, all the way around is 360. So we can figure out each angle by doing 360 divided by 6, and that ends up being 60 degrees. So we turned it just 60 degrees about the center for it to overlap. Okay, this is not so bad. Equilateral triangles have rotational symmetry. If you locate the center, we see that we can turn it through this angle and it'll overlap itself. We kind of turn it 1/3 of the way around the circle. Okay, so we can figure out what this angle is just by taking 360, which would be all the way around, and dividing it by 3 because we have 3 equal angles here. So 360 divided by 3 is 120 degrees. That's the angle of rotation for that figure. Okay, take a look at this guy. Well, not him. This one. We'll get back to the zebra. Alright, so this time it's kind of got complicated. Hard for me to draw lines from the center to the tips, but I'm just going to count how many times we can turn this until we get it all the way around. So if we start here, we turn it once to get there, twice to get there, 3 times to get there, 4, 5, 6, 7, and if we turn it 8 times, we're back where we started. So the way we figure out the angle of rotation is take 360, and we did it in 8 turns. So 360 divided by 8, and that's 45 degrees. Okay, kind of cool. All right, now it's time for the zebra dude. Let me see. Does the zebra have an rotational symmetry? Absolutely not. Poor zebra dude. The only way we can get this to overlap itself is if we turned it all the way around, 360 degrees. But that's true of every figure. So this one does not have rotational symmetry. So we'll just say no. All right, sorry zebra guy. All right, this brings us to our last example. I told you this was quick this time. So we have a blue octagon here. And it certainly does have some rotational symmetry. If we divide it up into 8 triangles here by drawing the lines from the center to the vertices of the octagon, we see that we've divided 360 degrees by 8. So remember, all the way around is 360 degrees. There are 8 angles around here. 1, 2, 3, 4, 5, 6, 7, 8. So each angle would be 360 degrees divided by 8, which is 45 degrees. We had that one below. So that's the angle of rotation for the octagon. Okay, we've made it to the journal assignment already. So for each of the 3 figures below, they all have rotational symmetry. Your job is to find the angle of rotation. All right, good luck.